Okay guys, so today we're going to take notes on absolute value, powers of 10, and scientific notation. So the sub should have given you a blank copy of the notes, and you are going to follow along with me and fill out whatever I write down. The nice thing about the video is if you didn't understand something, you can rewind and play it again. Okay? You can also access this video at home, so when you're working on the homework tonight, if you still don't understand, you can rewatch certain parts by rewinding or fast forwarding. Okay, so let's begin. Let's start with absolute value. Absolute value, which you should probably remember from 6th grade, is a number's distance from 0. What that means is how far away is that value from 0. So the symbol looks like these bars, and there's a number inside of the bars. Okay? And for example, if I gave you the absolute value of 3, that value is 3. Because 3 is 1, 2, 3 spaces away from 0. So what you will notice is absolute value is always a positive number. Okay? Meaning distance is always positive. Whenever you describe distance, it's positive. You never say that I am traveling negative miles to get home, for example. Okay? So let's look at some practice problems. How far away is 3 from 0? Well, we already did that one. It's 1, 2, 3 spaces away from 0. How far away is 9 from 0? It's 9 spaces away from 0. How far away is negative 2 from 0? It's 2 spaces away from 0. How far away is negative 10 from 0? It's 10 spaces away from 0. And lastly, how far away is 0 from 0? It's 0 spaces away. Notice how all of these distances are positive. Whenever you're comparing absolute value, you need to simplify the expressions before you can compare. For example, in number 1, I need to first find the absolute value of negative 14. So negative 14 is 14 away from 0. Negative 19 is 19 away from 0. So essentially now I'm comparing 14 to 19. And I want to compare with the symbols less than, greater than, or equal to. So 14 is less than 19. Okay? Negative 41 is 41 away from 0, and 41 is 41 away from 0. So these absolute values are equal. Okay? For this one, I'm actually going to have to do negative 16 minus 5. So negative 16 minus 5 is negative 21, and 7 minus 17 is negative 10. Okay? And so now the next thing I would want to do is I would want to find the absolute value of negative 21, which is 21. And I would want to find the absolute value of negative 10, which is 10. And therefore 21 is greater than 10. So again, you actually have to simplify what's in the absolute value first. It kind of works like parentheses in PEMDAS. Okay, so next here, I'm going to do negative 22 plus 8. Okay, so I'm going to find that first. Okay, and remember, you want to try not to use a calculator, so if you have to go over here and you have to subtract, you can do that, okay? So that's negative 14. And then negative 9 minus 12 is negative 21. Okay, and then now the absolute value of negative 14 is 14, and the absolute value of negative 21 is 21. So essentially, I am comparing 14 to 21. So 14 is less than 21. Good. Okay, so let's go ahead and move on to the next page here. Okay, so hopefully you're comfortable with absolute value. It's pretty simple. Again, it's a number's distance from 0. So the next part of the notes is powers of 10. So yesterday when I was here with you guys, we learned about square roots and positive exponents. Well, what about negative exponents? Yes, they exist too. So let's understand how we investigate them or write them out. Okay? So it says write the exponent in expanded form, then evaluate it. All right? So remember, 10 to the 5th power does not mean 10 times 5. It means in expanded form, 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5. And this only works with the 10s. We can do a shortcut, meaning we know that since we're multiplying 10 5 times, that essentially we're adding 5 zeros there. Okay, I have 4 zeros there, so let me fix that. We need 5 zeros. So this value is 100,000. Again, this trick where you add the zeros only works for the 10. So 10 to the 4th means 10 times 10 times 10 times 10. So 10 times itself 4 times, not 10 times 4. And so the trick tells us that we can add 4 zeros. So this value is 10,000. 10 to the 3rd means 10 times 10 times 10. And remember, dot means to multiply. And so if I add 3 zeros, this value is 1,000. And 10 to the 2nd means 10 times 10, which we know is 100, or we can use the trick, which tells us that we add 2 zeros. 10 to the 1st is just 110, which is still just 10. And 10 to the 0, remember that anything to the 0 power is 1. Okay, so these two are going to look the same. Anything to the 0 power is 1. It says, what do you notice about the power in the numbers 0, 0 behind the digit 1? Well, as I told you the trick, the power tells you how many zeros go behind the 1. And again, this only works for the tens. Only works for tens. Okay, make sure you really understand that it only works for the tens. Okay, so as we can see is that these positive exponents make these numbers very large. 100,000 is large, 10,000 is large, 1,000 is large, okay? So let's look at some negative exponents. Now look at the following negative exponents of 10 shown below. Noticing that these numbers are always blank. Okay, these numbers are always decimals. Also, the zeros are always placed in front of the digit 1. Can you find a pattern between the power value and the decimal? Okay, so the negative powers do not mean a negative number. Okay, they do not mean a negative number. Okay, they mean that the value is a decimal or it is small. So for example, 10 to the negative 1 means 1 in the 10th place, which we know is 1/10. Okay, 10 to the negative 2 means 1 in the 100th place, which we know as 1 over 10 times 10, which we know as 1 over 100. 10 to the negative 3 is a 1 in the 1000th place, which we know as 1 times 10 times 10, which is the same as 1 over 1,000. These are called equivalencies, meaning 10 to the negative 3rd, 1,000, 1 over 10 times 10 times 10, which is the same as 1 over 1,000, are all the same. It's 1, 2, 3, 4 different ways of writing the same thing. 10 to the negative 4th means 1 in the 10,000th place. So that's 10 times 10 times 10 times 10, which is 1 over 10,000. And 10 to the negative 5 is 1 in the 100,000th place. Tens, hundreds, thousands, 10,000s, 100,000s. That's why it is 10 times 10 times 10 times 10 times 10, which is the same as 1 over 100,000. What you will notice is these values are the same as the above values except over 1. Okay? So if you know 10 to the 2nd, for example, you know that 10 to the negative 2nd will be 1 over 100. Okay? Because it's the reverse. 10 to the 2nd equals 100, so 10 to the negative 2nd is 1 over 100. Summarize your class discussion for how to write out negative exponents. Okay? You can also use the trick here. So I'm going to give you a little bit of another trick here. So for 10 to the negative 3rd, since we know that our negative exponents mean decimal or fractions, what I can do is I can add 3 zeros, including the leading 0. Okay, so these are the same. And I know that because 1 is in the thousandths place. Tenths, hundredths, thousandths. Okay, so for 10 to the negative 4th, that would equal 4 zeros, including the leading 0. So the leading 0 is this number in front here. So this is tenths, hundredths, thousandths, 10,000. Okay? All right? So hopefully you'll start to notice a pattern there. Okay, so let's continue with our notes on to the next page. So the next page says practice. Fill in the chart with the missing values. Okay, so I've got 10 to the negative second. I know that my negative exponents are very small values because our negative numbers are on the left of the number line. If you remember the number line, here's 0, here's 1, and here's negative 1. Our negative values are to the left of 0. Okay, so 10 to the negative second means 1 over 10 times 10. And 10 times 10 is 100. So the decimal is 1 in the hundredths place. Remember, it's 2 zeros, including the leading 0. Here I have 3 tenths, and since it's written as a fraction, this means that this is 10 to the negative third. So this simplifies to 1 over, remember, 10 times 10 times 10, okay? So 10 times 10 times 10, so 1 over 1,000, and that's the same as 0.001, 1 in the thousandths place, tenths, hundredths, thousandths, okay? Here, I've got 1, 2, 3, 4 zeros, including the leading 0. So this is 10 to the negative 4th. So we know that this is the same as 1 over 10 times 10 times 10 times 10. Okay? And next we have 10 to the negative 6, which is 1 over 10 times 10, 6 times 1, 2, 3, 4, 5, 6. And that means I'm going to add 6 zeros, 1, 2, 3, 4, 5, 6, including the leading 0. Okay, so 1, 2, 3, 4, 5, 6. So this 1 is in the tenths, hundredths, thousandths, 10,000s, 100,000s, the millionths place. Okay, the 10 million. Okay, all right. So over here we've got 1, 2, 3, 4, 5 zeros. So this is 10 to the negative 5th. I purposefully went out of order here to see if you're noticing. So I've got 10 times 10 times 10, 1, 2, 3, 4, 5 times. And you can notice I have 1, 2, 3, 4, 5 zeros, including the leading 0. And 1 over 10,000, I have 1, 2, 3, 4 zeros. And since it's a negative, it's 10 to the negative 4th. And that's 1, 2, 3, 4. That's tenths, hundredths, thousandths, 10,000. That's 1 in the 10,000ths place. Okay? So hopefully you're able to see the connection here between exponent, fraction, and decimal. Okay? All right, so the next part says write the power value of the exponent in the box and then evaluate. So since there are 3 tens here and it's 10 times 10 times 10, this is a positive exponent. Okay, positive exponent, which means that this value is very large. In fact, this value is 1,000. There is 1, 2, 3, 4, 5 tenths here, so 10 to the 5th power means I'm going to add 5 zeros. And again, since this is a positive exponent, this value is very large. So this value is 100,000. 1, 2, 3, 4, 5 zeros. Okay. All right. It says, number 3, which of the following is equivalent to 10 to the negative 4th? Remember, equivalent means equal. So which of these values is equivalent? Well, since it's a negative exponent, I know that it's going to be a decimal or fraction. So all I really need to look at is which of these has 1, 2, 3, 4 zeros. The correct answer is C. Okay? You can also remember how to do this as 1 over 10 to the 4th and simplify that. Again, the next question asks, which of the following is equivalent to 10 to the negative 3rd? Remember, that means equals. And since it's 10 to the negative 3rd, we're thinking 1 over 10 to the 3rd, which is 1 over 10 times 10 times 10. And the value that shows that is 1, 2, 3. That's this one. 1 in the thousandths place. Okay? Because we know that 10 times 10 is 100, and 100 times 10 is 1,000. Okay. Next, it says which is not equivalent. This question is asking which is not equivalent to 10 to the negative 2nd. So here's where you need to know multiple representations of the same thing. So 10 to the negative second is the same as 1 over 10 times 10, which is the same as 1 over 100, which is 2 zeros with the leading 0. Tenths, hundredths. So this is, and this is. A is not because 100 actually represents 10 to the positive 2 and not 10 to the negative 2. Okay? Lastly, which is equivalent to, okay, again, equivalent means equals. This is a decimal, and our decimal values do not mean negative values. They mean small values. So I'm going to go ahead and eliminate those knowing that it's not negative. I'm going to count the zeros. 1, 2, 3, 4, 5. So since there are 5 zeros, 1, 2, 3, 4, 5, the correct answer here is C. Because 1 over 10 to the 4th would be 4 zeros, and that is not what I have here. Okay, so hopefully you get that. Okay, so off to the last part of the notes, which is scientific notation. Again, hopefully this is a review from 6th grade. It says when are numbers written in scientific notation? So we use scientific notation to represent very large or very small numbers. Okay, so write that down. Very large or very small numbers. So if you think about this in a real world context, some very large numbers are the distance from here to the moon. Okay, we wouldn't want to write out that value with all of the zeros, so we would use scientific notation. We would also use scientific notation for very small numbers, like the size of a cell. Okay, cells are known to be very, very small, so we would use scientific notation to represent those very small numbers. Okay, so standard notation are normal numbers that you're used to. For example, 12,400, 502,813, 8,643,500, or 0.4901, which you would use place value to read that. So that's tenths, hundredths, thousands, 10,000. So it's 4,901 10,000. Okay, and so forth. Scientific notation is some number times 10 to some power. If you notice, all of these numbers are between 1 and 10. So the first front number is between 1 and 10, and then we multiply it by some power of 10. And I'll explain that more here in just a second. So it says by converting numbers from blank form to blank form, okay, so by converting numbers from standard form to scientific notation, you are rewriting the numbers to be a number between 1 and 10. And that's what I was talking about up here. All of these values are between 1 and 10. So, the left side of this chart says convert each to scientific notation. So right now in 94,508, the decimal's at the end. So I'm going to move the decimal until I have a value between 1 and 10. So I'm going to move it once, twice, 3 times, 4 times. So now I have 9.4508 times 10 to the, okay, so 9.4508 is between 1 and 10, and I moved 1, 2, 3, 4 times. And it's going to be a positive 4. The reason why it's a positive 4 is because the number I started with is large, okay? Our positive numbers are to the right. They are bigger than our negative numbers, okay? Let's try another one. The decimal is in the back of 309. I'm going to move the decimal once, twice. 3.09 is between 1 and 10, and since I moved twice, it's 10 to the positive second. Again, it's because the number I started with is large, and our large numbers are to the right of the number line, okay? Here, I'm going to, this number is very small. In fact, it's tenths, hundredths, thousandths, 10,000, okay? Tenths, hundredths, thousandths, 10,000. And so I'm going to move the decimal once, twice, 3 times. So this value is 8.5, which is, again, between 1 and 10, and times 10 to the negative third. The reason why the exponent is negative here is because the value you started with is small, and our negative values are to the left of the number line. Okay, so I'm just going to double check. Once, twice, 3 times. Yes. 8.5 times 10 to the negative third. Okay, so this part of the chart is where numbers are in scientific and you want to go to standard form. So here is where the exponent tells you how many times to move. The exponent does not tell you how many zeros to add. Okay, that is a common misconception. So the decimal right here is 6.28. So I'm going to move once, twice, 3 times. I'm moving 3 to the right because my positive values, remember, are to the right of the number line. So I end up having to add just 1 0 there. So this number is 6,280. I can double check that by doing the reverse. I can go once, twice, 3 times to the left, and I get what I started with, so I'm good to go. All right, again, so this next one, the exponent is 5. Since it's a positive 5, and my positive values are to the right of the number line, I'm going to move. I'm just going to rewrite this here so I have more space. I'm going to move once, twice, 3, 4, 5 times to the right. So my decimal now here is at the end, and I'm left with 811,017. That value is large. Now this exponent is negative 2, and since my negative numbers are on the left of the number line, I'm going to move this decimal 2 times to the left, once, twice, and I'm going to add a 0. So this number becomes 0.053409. Okay? So again, the exponent does not tell you how many zeros to add. Remember, that only worked for the tens, the powers of 10. So you actually have to count. It does not mean to add that many zeros. Okay? So right now, what you can do is you can practice converting each of these to scientific, and you can practice converting each of these to standard. And you can pause the video so that you can try that on your own. And then you can come back and check. Okay, so you should have tried these on your own. So again, we're making this scientific, so we need a number between 1 and 10. So we're going to move 1, 2, 3, 4, 5. So this is 7.56 times 10 to the 5th power. Remember, it is a positive 5 because the number we started with is large. Okay? This value I'm only going to move once. So this is 1.2094. Now this value is between 1 and 10. And since I moved once, and the value I started with is small, it's going to be 10 to the negative first. So this value is small. Okay? The decimals here at the end, 1, 2, 3, 4, 5, 6. This becomes 5.982091. And because the number I started with is large, it's times 10 to the 6th power. Okay, in this next section, you are converting to standard form. So you're using the exponent. Remember, the exponent tells you how many times to move and in what direction. It does not tell you how many zeros to add. Again, that only works for your powers of 10. So I'm going to move twice to the right. So that number is 567. This negative 4 exponent means I'm going to move 4 times to the left. So that's going to give me if I moved 4 to the left, 1, 2, 3, 4. Yes. Okay, that's that number. And then this means to move twice to the left. So once, twice, this becomes 0.0399. Notice again that I did not add 2 zeros. I'm moving twice to the left because my negative values are to the left. Okay? All right, so we're almost finished. This is the last section of the notes. I know they're a little bit longer today, but most of this is a review, hopefully. Parts of it may be new to you, such as the powers of 10. Okay? It says, order the following from least to greatest. It says show work. If you need a little more room to show work, you can always use your warm-up notebook or the bottom of this page. Okay. If you look at number 1, you should notice that they're all in scientific notation. A little trick is you don't need to make these standard form. You could just look at the exponents. If I look at the exponents, I can order these numbers based on these exponents because none of the exponents are the same. Okay? And so since it's least to greatest, I'm going to start with my negative exponent. 6.98 times 10 to the negative third would be first, because negative 3 is the furthest away from 0. Next, negative 2 is the furthest away, so that would be second. Okay? Okay, so it's least to greatest. Now I'm comparing 4, 4, and 7. Now, since these 4s are the same, I actually have to look at the front value. So I have 4.016 and 4.045. So 4.016 and 4.045. The 4s are the same, the 0s are the same, but 1 is smaller than 4. So I'm going to do this one next. This is third. Okay? Because it's least to greatest. Okay? This is 4. And this is fifth, because 7 is the largest exponent. So you don't need to make these all standard. You can just compare the exponents, because remember, the positive exponents mean that you're going to move to the right. The values are going to get larger. And the negative exponents mean you're going to move the decimal to the left, and the values are going to get smaller. Okay? Now, in numbers 2 and 3, I've kind of mixed a couple of different things we've already learned. So we need to do some conversions. So I'm going to give you a few minutes to do some conversions in numbers 2 and 3. Okay, so do some conversions, and then in just a second, I will post the answers to those problems. Okay, so let's continue to look at number 2. So what I've done here for number 2 is I went ahead and converted some of these. For example, 10 to the negative second is 1 over 100, which is 0.01. Okay? So now that these are all decimals, I'm able to write them from least to greatest. And I need some more room, so I'm going to do that here at the bottom. So I'm just going to write number 2. Okay, so let's start with my negative values. My negative value, so I have negative 3.20, which came from negative 320%, and I have negative 3.15. So the larger numbers on the negative side are actually smaller. So I'm going to start with negative 320%. That's going to be first. Then it's going to be negative 3.15. Okay, now I'm going into my positive value. So I took care of that one, and I took care of this one. Okay, so out of my positive values, I have 0.01, I have 1.5, I have 2, and I have 0.0205. So the next smallest would be 10 to the negative second, because remember that's 1 in the hundredths place, okay? Then it would be 2.05 times 10 to the negative second. Remember, even though you made them all decimals, you want to write them in their original form. So I took care of that, I took care of that. Next would be 150%. And last would be the absolute value of negative 8 plus 10, which was 2. Negative 8 plus 10 is 2, and 2 is 2 away from 0. Okay, so I'm going to do 3 down here too, so I have enough room. Again, I made these all decimals. So 13.5%, I made a decimal. Negative 0.2, I found the absolute value. This one was good to go. 10 to the 0 power is 1. This one I moved once to the left, and this one is 1 over 1,000. Okay, so let's see here. The smallest value here is 10 to the negative third, because that is 1,000. Okay, so I took care of that. Next would be next smallest, least to greatest. So the next smallest would be 13.5%. Okay, because remember that's 0.135. Then we've got 1.45 times 10 to the negative first. Okay. Then we have 0.1456. Negative absolute value of 0.2. And lastly, 10 to the 0, which is 1. Okay? If this confuses you, you can always line up your decimals. This is what I mean. 10 to the negative third was 0.001. I'm going to line that up with 13.5%, which is 0.135. Okay? And I'm going to line that up with 0.145, which is 1.45 times 10 to the negative first. That means move 1 to the left. And then I'm going to line that up with 0.1456. Okay, and I'm going to add zeros here for placeholders so that they're all the same amount. And then I have 0.2. I'm going to add all those zeros for placeholders because remember, it's the absolute value of that number. And 10 to the 0, any number to the 0 power is 1 whole. So I can see now using place value that this is least to greatest. Okay? So remember, you always want to make values the same so that you're able to compare them. And then when you're ordering them, you want to use the original form. Okay, so that concludes our lesson on absolute value, power to 10, and scientific notation. Again, you can access this video at home, so if you need to rewatch parts that you weren't sure of, you can do that, okay? So I will see you when I get back. Thanks, guys.